you to do this. Just so you know, I've asked you to solve about 17 different things today. The whole word of all of them is solve. Solve just means give me variable equals number. We agree? So we went over, we could do common base, but common base doesn't always work. They have to be able to be made into a common base. But I told you to spot them is often when I gave you that really ugly one today where it was like, this is the power of this times this is the power of this over this is the power of this equals this, so this is the power of this. Like, it's like, wow, if I have to log base 10, both sides on that one, I'm going to be a little sad. Okay? Then we went over word problems where you had to solve, correct? Then we went over where I gave you two bases, two exponents, and they weren't common base, so we had to log base 10 both sides. One where I gave you a coefficient and two bases with exponents, you had to log base 10 both sides and use the multiplication law, correct? Then we went through today how if I give you just a number equals a base to an exponent, we can convert. And that's what we're going to look at today. So say I give you this, the most basic one. 3 equals 4 to the x plus 1. Yeah. What are we going to do?
Log.
Now you could log base 10 both sides, but when you see this, you should think, wow, there's a faster way. And it's when I have a number without an exponent equals a base with an exponent, correct? I can convert to a log. Now I told you, how do we do that? We go log. Now the base of my exponent becomes the base of my log, and when I convert backwards, the base of my log becomes the base of my exponent. As long as I remember that bases stay the same and friends don't, you can convert really, really easily, I'm telling you. And in order to convert, this is the other thing you need to know, to think about when you convert. There needs to only be 3 pieces of information. If there's more than 3, you have to do something to the equation first to get the 3 pieces of information in order to convert. If you have more than 3, you cannot convert. Okay? All right. So the base of my exponent becomes the base of my log. Currently, what is friends with it? X plus 1. So is it going to stay friends?
No.
No. So what's going to get put beside the log? The 3. And it's going to equal x plus 1. And then we subtract our 1. And we get log base 4 of 3 minus 1 equals x. And x equals something. Now, every single person is typing this in. If you have the log base button, you're going to be using that button. If you have the TI-83s, how are we going to type this in? We're going to go log 3 divided by log 4, hit enter, then subtract 1, correct? So if you don't have the log base button, if you have a TI-83 and you do not have the log base button, you are going to have to type it in like this. Minus 1. Now, anyone with the log base button can type it in that way too if you were like, wow, that's way too easy. I want it a little more complicated. You can go that route. No one's stopping you. What do we get to the nearest tenth?
0.2.
Here it is.
-0.2. Yeah.
Okay. Let's look at this. Next say equals, sorry, 4 equals 2. Okay. This one has how many pieces of information?
4.
There's 4. We have 4 pieces of information. Can I convert it to a log if I have 4 pieces of information?
No, not yet.
No. What can I do? Divide the 2. Do not make this be 6. Please. Please don't. They will have the answer to that. Please, sir. Don't do that. So we have to divide the 2 over. The reason why we can't make the 2 join the 3 is because the 3 has an exponent. But we can divide by 2 because 4 divided by 2 was taught to us in elementary school. And we know that's real. We can do that. 4 divided by 2 is 2. Now, do we have 3 pieces of information now? Yes. And when we have 3 pieces of information, we don't have to log base 10 both sides. We could convert, correct? So if we go to convert this, we're going to get log base what? 3 because the base of my exponent becomes the base of my log. That's the very first thing I will always deal with is base to base. Then what is friends does not stay friends. So what is currently friends in exponential? 3 and x plus 2. So what's going to actually be the friend now? The 2. And it's going to equal x plus 2. And then we just subtract 2. And what do we get?
Negative 1.4.
Sorry?
Negative 1.4.
Negative 1.4? Okay. What if I do this? What if I do this? What if I go 2 to the x plus 1 equals 3 to the x? Yep.
Then you just get the x to the other side, so then you can answer the question.
How do you move the x to the other side?
What? You'd be able to,
Guys. Yeah. Did you what?
are you able to subtract it or root it away?
Nope. This is a trick question. I put it in the wrong section. You can't actually can't convert this. Why can't you convert it? It has an exponent on both of the bases. Remember, my rule was it has to have a number equals a base to an exponent, correct? The moment it has 2 exponents, I'm forced to do what? Log base 10. If Peter was paying attention, he would have enjoyed saying that answer, but he wasn't. So, we would log base 10 both sides. We can't convert this. Do you see that? I set you up, just so you know, to prove a point. Because people don't know when they can and when they can't. You cannot if you have 2 bases and 2 exponents. If you have a number equals a base with an exponent, you can. Okay? So this one you would have to log base 10 both sides. I'm not actually going to do the work because we just did these in our daily thing, but I just want to prove a point that this one cannot be converted. Okay. Vice versa. Yep.
2 things.
Yeah.
First, exponents need to be subtracted. It's a log 10. Also, what? I don't know, I'm feeling. Why wouldn't you be able to put both to the root of x, and then that would give you 3, and then something weird on the other side?
Because you just said something weird. That would still be something weird on both sides. The root of x would still be weird on both.
Because you get 2 raised to the x plus 1 over x equals 3. I don't know even how you'd solve that, but it's okay.
You're just making your life harder.
I know. That's what I thought when I saw it.
You could, but why? But you
Okay.
could. And then you could convert, sure.
Okay.
Which is kind of what Chris was saying. I wouldn't
So
go
it
that
wasn't wrong.
route. Yeah.
Okay.
You'd have to divide, though. You'd have to raise it to the power of 1 over x. And most of the time, I'm not nice and gave 3 to the x. I would give like 3 to the x plus 2, and now you're raising it to the power of 1. Oh, so just stop.
Okay.
But not wrong,
Just weird.
just harder. It's fine. Okay, so what if I do this? So, we know that when we have an exponential, we need to get it to a log when the exponent is the variable, correct? Because we need to get that exponent to come down and then we can actually do some math, right? We know that. We know that when we have an exponential and our variable is an exponent, exponent is a variable, sorry, we have to get it into a log so the exponent comes down and we can solve it like we did in junior high, correct? Now, logs, when do we have to convert? Well, if they say convert it, but they don't often do that. They'll often say solve, and you need to know how the heck you solve a log, okay? Now, it has 3 pieces of information, does it not? It has a base, it has what's beside, it has what it's equal to. 1 log equal to a number, just like an exponent equal to a number. When you have a log equal to a number or an exponent equal to a number, you can convert. That's the conversion rule, okay? So my exponent was equal to a number, I can convert. If my log is equal to a number, I can convert. We agree? Why do we want to convert? Well, there's 2 ways. When the x is beside the log, it's locked in with the log. I don't know how to solve that. Do I divide and I subtract 1 off it? No, it's locked in with the log, right? It's a bracket. It's bracketed in with it, correct? So the only way I can get that x plus 1 to be somewhere where I can actually work with it is to convert it. The other place when I want to convert to exponential when I'm solving a log is when the variable's down here in the base. How do I get that by itself? How do I get a variable and a base by itself? I don't know. The only way I can do that is if I convert to an exponential. Okay? So when your variable is in the base or your variable is beside the log, I have to convert to exponential in order to solve it. But you know you can convert to exponential the moment that you have a log equal to a number. Okay? An exponent equal to a number. Conversions can happen. You can convert back and forth. Okay? So how do you do a test on exponentials when you need logs to solve exponentials? How do you do a test on logs when you need exponentials to solve logs? You kind of have to do a test together. So, all right, the base of my log becomes the base of my exponent. So I'm going to get a 4, and then I need something in my exponent equals something. I'm putting blanks because I need things, right? So what's friends currently? What needs to be friends now? The 6 and the 4. So I'm going to put a 6 up here, and then it's going to be x plus 1. And then all I have to do is subtract 1, which is a large number. So, could we y1, y2 this? We can y1, y2 any solving. Trig, in polynomials, in logs, in exponentials. The moment it says solve, we have the ability to y1, y2. Now, if we leave it the way it is, if there's something on this side and something on this side, y1, y2, we find the intersection. If we move everything to one side, set it equal to 0, what are we finding? The x-intercepts. It's very different, and they can sometimes ask us questions like that, right? So for y1 and y2, and we have two different things on both sides, we're finding the x of the intersection. If we set it all equal to 0, move everything to one side, we're finding the x-intercepts. Okay? So we can find it for this one. We have found the answer is 4,095 in the x, correct? So if your x maximum is not bigger than 4,095, no matter how much you hit second trace 5, enter, enter, enter viciously, it ain't giving you an answer. Because it can't find 4,095 when your Windows max is 10. Okay? So always think, when you're trying to find the intersection, I'm hoping that this is your way of checking and not your way of trying to solve every problem. Because that's not going to work out well for you when they say algebraically, or they do it in a way that forces you to do it algebraically, right? But I hope you are checking it. And by checking it, I have an answer of 4,095. So I go to my x max and I immediately make it bigger, and then I find out where they intersect. Okay? All right. What happens if I give you this? How many pieces of information do I have?
4.
4. So I do have a log equals a number, which was what I told you I had to have. I have to have a log equals a number before I can convert. But my other piece of information was I need to have 3 pieces of information. If I have more, I have to do something so that I do not have more. So what could I do? Yeah, and some people do 2 different things. I could divide the 2 over. That's where my head goes to immediately. But remember, we did the power rule when we were solving exponents. We log base 10 both sides. We took the exponent and we dropped it in front. Could we not take the number in front and bring it up to the exponent as well? So instead of divide, I'll do it 2 ways. This way is the way I would immediately go. But remember, you have to match your answer to their answer, so you have to watch, right? So I'm going to go 6 equals log base x of 6. And now I actually have it in the format I need. So the base of my log becomes the base of my exponent. What's friends isn't friends anymore. They happen to both be 6s, so this is confusing. Equals 6. How do I get rid of that 6? You could 6th root, or you could raise it to the power of 1/6. Hey, what if we use the power rule the other way? Instead of dividing, we could bring this up, and you can only do that with logs. So I would get 12 equals log, technically x to the 6th squared. So I get 12 equals log base x of 36. then I still convert. X base to the 12 equals 36, and then I raise it to the 112. Do either way though. Same answer.
Free will and giving us options. Free will is a mistake.
Okay. One other rule I want to go with. Well, these are two special rules. I'm going to start them because people forget about them.
Oh, maybe there. I remember.
Oh, and one thing I forgot to say too, sorry. If I give you something like this, 3 equals log x, what should I immediately do? Yeah, no, not log base 10 both sides. You were close, you wouldn't have said both sides. This is a log what? It's a base 10. So if it doesn't have a base, I immediately put the 10 in there, because then I can convert, right? 10 to the 3 equals x. So if you don't have a base on your log, go put a 10 in there, because it is base 10. Just like the square root, the index is 2, even if it isn't written. Okay, rules to remember. If I give you log base 5 of 5 to the 6. Type it in. See what you get. If you have the old calculators, you're doing log 5 to the 6 divided by log 5.
It's lets you know whatever you want.
Should not be one.
Should be one. Should be one. No.
56 in the bracket.
Oh, it's why I shouldn't use that. I switched to log afterwards. That's what I was thinking.
Okay, so what's your answer? Okay. Type that one in. What the heck? Why is that happening?
Yes.
What can we do with our exponent? It could actually, instead of staying up there, it could drop in front, so let's look at it that way. So I get 3 log base 8 of 8. What is log base 8 of 8? Why? Because actually every single time you're doing a log, you don't know this, but it's saying this to what power is this? Or you also, if you have the TI-83s, you know your log base 8 of 8, you know in order to type that in, it's like this. And what's log 8 divided by log 8? 1. So that rule. But also what you're doing, your calculator, every single time it's doing a log, you don't know this, but say it's going, you might know this, but now you will know this. Say it's doing this. You're always typing it in. What your calculator is actually doing is it's saying 2 to what exponent gets me this number? 2 to what exponent gets me 8? What would 2 to what exponent would give me 8? 3. So the answer when you type this in is going to be 3. If I go log 3 and a 9 beside, it's saying 3 to what exponent gets me 9? It'd be 2. So that's all it's doing every single time. Okay? So if I go here, 8 to what exponent gets me 8? 1. So it's actually 3, right? So the note, the actual rule to remember is if I give you log base a to the b, let's say, what would my answer be?
E.
It would be b. Twofold, because you can memorize the rule. A to the b. When you start sounding like you're kind of crazy, like 6 to the 6 to the 7, your answer is 7. 9 to the 9 to the 2, your answer is 2. Okay? You can either do it that way, or you can say, hey, I can drop that b in front, and then I get log base a of a, which I know is 1, so it's b. So that's one rule, okay? Your other rule is, what if I do this? This is the other one that's forgotten about. Well, let's sidetrack and do some numbers instead of variables, right? So say I go log 6, 1. Type that in. You're going to get 0. If I do log 8, 1, I'm going to get 0. Because I told you, what does your calculator do every single time it does this? It says this number, so the 6, to what exponent equals 1? 0. 8 to what exponent equals 1? 0. X to what exponent equals 1? 0. So whenever the number beside your log is a 1, the base doesn't even really matter what it is. Your answer will be 0. Right? Because any base to 0 must be 1. So these are the two rules, I'm not joking, that are often forgotten about, but are very important to being able to solve logs. Okay? I'm going to give you a few questions, and then you want to have homework. Ready? See if you can do this. I write them on the board here. Log. No, I'm not. I want this ridiculous smartboard for so many reasons, including its eraser. Now I have smartboard jealousy.
He doesn't.
This is a dumb board. He doesn't like his either?
He likes his one beforehand better.
Me too. Give me ancient times. I'd rather have my ancient one back. I want it back. I don't know where they put it. But I actually at this point I feel like I can't record a chalkboard. But
You
it's
could just use like a computer.
actually chalkboards just for another thing. I would like to have a whiteboard. I don't want I don't want to go that far. I don't want brushes, which you don't know, but I was a brush cleaner in my day. I even had like this thing that you could put the brush on and it would go and then it would pull the chalk off. The more you know. Okay, log 4096x equals 64. So I want you to solve this one. Number 2. If I give you this, log base 2 of x equals 3. And log base 2 of t equals x. What is the value of x? Or, sorry, what is the value of t? That's the t, even though my board hates me. It'll come back. Don't freak out. Then, you have 2 more. Log base b of 81 equals 2/3. Value of b to the nearest whole number. And then log base a of b equals 4.5 log base A of C equals 3.7. See, I could have you do the textbook questions where you just convert back and forth, and then they give you this questions. I'd rather you practice this. This is more. Then the value of log base A of B divided by C to the nearest tenth is. Now the great thing is this isn't in a test right now. This is in a lesson where I made you convert from logs to exponentials and exponentials to logs, correct? So what am I probably going to make you do for all 4 of these? Convert, right? Convert. So at least when it's in a test, you have to be like, okay, what did they ask me to do? Right now, you know there's 4 questions after the conversion lesson, okay? So try the questions.